Hi friends, good evening, and today we will talk about a problem called a distinct power, which is nothing but problem number 29 in Project Euler. What does this problem tell? So it's asking us to consider all integer combinations of the form a to the power b, right? It's a power. So, but what is the range of a to the power b? So it says consider a to be in the range of 2 to the 5, right? So 2 to 5 inclusive, and b in the range of 2 to the 5 inclusive, and enumerate all the possible values of a to the power b in this range. So if you see here, it is enumerated. So starting with a equal to 2 and b equal to 2, 3, 4, 5, the different power combinations 2 to the power 2, 4, 2 to the power 3, 2 to the power 4, 2 to the power 5, like that a and b in the range 2 to the 5 are evaluated for the function a to the power b and their values are listed. Then, if they are placed in numerical order, basically the computed values, if they are placed in numerical order with any repeats removed, we get the following sequence of 15 distinct terms. So basically what they are telling us, you have to arrange the numbers in an ascending order, removing the duplicates. So if you see here, 16 is present 2 times. 2 power 4 is also 16. 4 power 2 is also 16. So they are asking us to count that 16 only once. So ideally, between 2, 3, 4, 5, there should be 16 values that is obtained. So 4 plus 4, 8, 8 plus 4, 12, 12 plus 4, 16. But the number of distinct terms is 15, which is what is enumerated here. Now the question is, how many distinct terms are in the sequence generated by a to the power b for a and b in the range between 2 to 100? So the example is given for us to understand the problem with a smaller range between a and b, ranging between 2 to the 5 inclusive. But the ask is to find how many distinct terms would be generated by the sequence evaluated for the expression a to the power b in the range a between 2 to 100 inclusive and b between the range 2 to the 100 inclusive. So this is the ask of the problem, and I've given the link of the problem to below. And let's go how we can visualize and understand this problem a little more better. So another way for you to visualize the problem is put it into a table. So if you look at the previous slide, in the problem description, they have given it as enumerated sequence of values. So all that we are doing is, there are two variables involved here, a and b. So create a table where every row and every column is denoted by this a and b. So the range of rows is a 2 to 5 as in the example, and the range of columns is also 2 to the 5 as in that example, and every cell is nothing but evaluation of this particular row raised to this particular column. So this value 4 is obtained by 2 raised to the power 2, and this value is obtained by 2 raised to the power 3. So it is another way to visualize, and we will realize that this is one of a better way to visualize this problem because it aids in solving this particular problem in a smoother way. So what is the ask? The ask is the same table, but the range is extended till 100. So I think once we solve this problem, we can extend the range to 100,000 or n arbitrarily, but the ask is still 100. So 2 to 100 on the column wise, 2 to 100 on the row wise. So compute these values and count only the distinct values is the ask of this problem. Now, where does this problem gets hard, right? So actually, if you look at it from the outset, you can do it, right? So 2 power 2, 2 power 3, 2 power 4, 2 power 100, 3 power 2, right? So you can compute the powers and then just find the distincts and return the answer. So where does this problem gets hard? So really the problem gets hard when it wants to compute these kind of bigger numbers. So take anything, right? So 2 to the power 75, 3 to the power 80. I'm just arbitrarily listing the numbers. The max is 100 to the power 100, right? 97 to the power 88. These are all very big numbers. So you can do a direct computation, right? Like you can't use a primitive data type like int or long, depending upon the programming language of your choice, because the computed values might fall outside the range of those primitives, but you can use some other data types, right? Like if you take Java, you can use a big integer, which indirectly uses an array to hold the values. There is no lower bound or upper bound as in the case of a primitive, but it is restricted by how much space you have in your RAM. So the direct computation is possible, but it's a little bit inefficient from a memory footprint perspective. And let's say even if you achieve using a direct computation method using data types like big integer or a string manipulation, etc. But once the problem extends tomorrow to like find the distinct values which is computed in the range 2 to 10,000 or 2 to 1 million, then even that's not going to suffice, because the heap memory is going to overflow, and probably you will have to get into some kind of distributed computing to get the same answer. But we will keep the direct computation, and we will try to look for is there some other better way to come up to the answer to this problem. And because this problem is quite a bit involved, I will try to make a few shorter videos rather than one bigger video. And we will stop here where we try to understand the problem. So we understood the problem. The problem is asking us to find the distinct values that is getting generated for the enumeration of the combinations a to the power b in the range 2 to the 100, and we visualize that as a table, and the direct computation gets a hard because that's not a very memory efficient way, and we will look for a better way to compute the problem. So we will stop this video here, and I will go into the next steps in the next video.